Hey everyone, last video for this particular lesson where we're talking about slope. So remember, slope is our quantifiable way, in other words, a numerical way that we can describe how much something goes up or down. And we're going to be referring to this a lot in the coordinate plane as we do this. So this next skill that we're learning right now is going to be something you're going to use for pretty much the remainder of this chapter that we're working on. So, and it's a really good skill to learn because it has to do with functions and with rates and everything. And so when you think about slope, I want you just to remember that above and beyond everything, slope is a rate. And a rate is just a way to describe how much something changes. That's all it is. It's a rate. When you're in a car and you're driving 65 miles an hour, it means that for every hour you're going 65 miles. And so slope is kind of the same sort of thing. And we'll talk a little more in depth about what a rate is in the next lesson. But just keep that in mind for today, that as we look at this formula, and you're going to see a bunch of X's and Y's, and it's really easy to kind of, glaze over. But it's a rate. That's what it is. It's a rate. Okay, so this is the slope formula that they give us in our resource that we use. And they give us all these y2s and y1s, x2, x1. So basically what they're saying is we're going to give you 2 points, all right? We're going to give you point 1, all right? And we're going to give you point 2. And so they're saying point 1, and we'll call it this point, is made up of an x coordinate and a y coordinate. And just so we can identify that they're with that point, we're going to use these subscripts. Right, a subscript is when it looks like a exponent, except it's down on the right-hand side as opposed to being up on the right-hand side. So that's our point 1. So that's just saying it could be any point, and then you take another point that's on the same line, but a different point, x2, y2, so a distinct point. So you got these 2 different points. And what they're saying is you can find the slope. Now, if you remember how we did this, right? We made a triangle, and we figured out how much did it go up and down. Well, if you think about how much it goes up and down, it's basically the difference between this y1 and this y2, right? So the slope can be written one of 2 ways. So you can say, well, it's the difference from this one to this one. So you could say it's y1 minus y2, all right? And then you would do the same thing for your x coordinates, right? And the one thing you got to remember with slope is it doesn't matter which coordinate you start with, but whenever you start with a coordinate, you always want to start with its companion in the same order. So if I start with y1, then I want to do x1 over here. And then minus x2. And if you look at it, it kind of looks like the set of coordinates. Like if you took this and sort of flipped it, it would be x1, y1, right? In your thing like that. So that's sort of what we're doing. So the formula that they give us, though, that they always want us to do, and I just want to tell you that order doesn't matter, but if it's easier for you to remember it, the formula they always give us is they always do the 2's first. So it's still you're changing your y over you're changing x, but now it's subtracting those y coordinates over the x coordinates. And remember, this is a set of your coordinates, and this is another set of your coordinates. And then at this point, the hardest thing is just watching for double negatives and all of that, and I'm going to do a few examples. So let's just dive into this and see what it looks like. Okay, so I've got this point right here, I4, 3, J2, 4. All right, so let's plot our points. So 4, 3 is going to put me right here, and then 2, 4 is going to put me right here. So if I look at this and I see what kind of a line I'm going to get out of this, okay? I'm sorry, I am not Khan Academy where I'm like locked in with this perfect, right? But I'm going to have, that's my triangle, right? My triangle goes from there, and I know that. But what if I can't draw it, okay? Well, so what they're saying is we're gonna call I4, 3, we're gonna call this x1, y1, and then we're gonna call this j set of points is going to be, sorry, why is it not writing? It's going to be our x2, y2. All right, and that's our j points. So if we're using, wow, I'm having all kinds of problems here. If we're using our coordinates, okay, it's going to be y2 minus y1 over x2 minus x1. Well, our y2 is this 4. So we put 4 in, so it's 4 minus, and then our y1 is going to be the y coordinate for I, and that's going to be 3. So we have 4 minus 3, and then we use our corresponding point that goes with this one, the first one here, so we're going to use our x, so 2, minus, and then my other x is 4. Alright, so you have 4 minus 3 over 2 minus 4, and then you simplify it. So 4 minus 3 gives me 1 on top, and then 2 minus 4 gives me negative 2. And if I simplify this, I have negative 1/2. So let's compare this to what we would get if we do this with our graph. Well, if we do it with our graph, I know that as it goes from left to right, it goes down. So I'm going to have a negative slope. It goes down 1 and over 2. So it's rise over run. So it would go down 1. So that's my negative 1 over 2. And that gives you your negative 1/2. So it gets you the same exact thing. All right. This is a faster way. Once you learn this algorithm, this is very quick, and you can do this. You just got to be careful because, like I said, there's a lot of ways to trip you up. So let's look at another example here. So the picture's there. If you want to draw the triangle, you want to stop and think about the triangle to help you. But I'm just going to do it with the coordinates. So we're going to say that R, I'm going to write this out, 1, 2, which is my x1, y1. And then my S is negative 4, 3, which is my x2, y2. I'm going to put it in my formula, my y2 minus y1 over x2 minus x1. So that gives me, my y2 is going to be this guy right here, 3. And then my y1 is 2. So I have 3 minus 2. And then my x2 is this one right here, negative 4 minus, and then my x1 is 1. So 3 minus 2 is 1, and then negative 4 minus 1, all right, which is the same thing as negative 4 plus negative 1. Another way of thinking about it is negative 5. All right, so my slope is negative 1/5, and we're going to call that m. All right, that's something I forgot to introduce. They like using this letter m for slope. All right. So m equals negative 1/5. I don't know why they use m and not s, but they use m. It probably has something to do with Greek and Latin word root, and maybe I'll find out one of these days. But m equals negative 1/5. So that's my slope. And if you look at this picture, it kind of makes sense, right? It's going down from left to right, so that explains the negative. And then 1/5 means it's going to be kind of a slow slope. Like it's not a real steep line. It's more of a slow decline. All right, last examples here. We got 2 real quick ones. We'll just kind of burn through these. So go x1, y1, x2, y2. So let's do my slope. So y2 minus y1 or x2 minus x1. So 3 minus 2. So 3 minus 2 over 5 minus 2. So this one gives me 1/3. All right, and I have this graph down here so that if you want to look at that and try and visualize where that would be, 2, 2 would be here, 5, 3 would put me here. So you'd have, wow, it's just epically bad drawing on my part. There you go. All right, that would be my slope. So that makes sense. Left to right, it's going up, and it's kind of a slow slope. All right, a slope of 3 would be something that would, be really steep like that, but that's not what we have. We have a slope of 1/3. All right, let's look at this last one. So we got x1, y1, x2, y2. Remember, your x coordinate is always first. Your y coordinate is always second. All right, think of the order of the alphabet. So y2, I'm going to just leave this right here. I'm not going to write it down again. So my y2 is negative 2 minus, and then this is my y1, negative 1/4. See that the way I wrote that? I did that very deliberately. And then we have negative 3 minus negative 7. So we've got a couple double negatives going on here. We've got one right here where these are going to turn into a positive, and this one right here. So this simplifies to negative 2 plus 4 over negative 3 plus 7. And then my final answer is going to be, well, negative 2 plus 4 is positive 2. Negative 3 plus 7 is positive 4, which gives me a slope of 1/2. So when I plot this and I draw this, the line should look kind of like this line a little bit. It's going to be a little steeper, but not much. But it should be going in the same direction. It should be going up from left to right. So let's see if it is. So negative 7 and negative 4 is going to put me down right here. And then negative 3 and negative 2, well, here's negative 3, and then we're going to go down to negative 2. And then, lo and behold, that's exactly what we got. They're very close to each other. The slopes are similar enough. They're not the same, so at some point they will intersect each other. But right now, they don't. So this is a good pictorial representation to check your work and see if it makes sense. So, again, the big thing with doing slope problems like this is just to make sure you're going slowly enough that you're putting your numbers in correctly. And so we threw a lot at you with this lesson, but if you're remembering your base formula, y2 minus y1 over x2 minus x1, and being very careful about how you're putting in your numbers, you should be good. That's our M. M is our slope. So good luck with these. And we are done.